Welcome back to Enzymes, Biological Catalysts. This time, we will see how enzymes use reactive groups to catalyze reactions. To get the most out of the videos, I recommend that you watch them in order. This is a reminder that this presentation is Dr. Johnson's intellectual property. There are three types of reactive groups in enzyme active sites. The side chains of amino acid residues are the reactive groups in many enzymatic reactions. Some enzymes make use of metal ions for catalysis, and others require coenzymes. When these groups react with the substrate to form covalent bonds, covalent catalysis is occurring. We saw this on the reaction progress diagrams with the enzyme altering the mechanism of the reaction. Enzymes make use of organic reactions to form covalent bonds with the substrate. There are a number of nucleophilic groups available, which are often part of the enzyme's active site as side chains of amino acids. They may also come from coenzymes. There are in addition a number of electrophilic groups involved in enzymatic reactions. These are more often found on the substrate or created by reaction between the enzyme and substrate. Nucleophiles are electron-rich, while electrophiles are electron-poor and subject to nucleophilic attack. To understand reactivity of amino acid side chains, you need to know the amino acid residues that are most commonly involved in enzymatic reaction mechanisms. These residues are involved in catalysis in a number of different ways. General acid-base catalysis involves the transfer of protons between substrate and enzyme during the reaction. Residues that can readily ionize are typically involved in this type of reaction. Some residues are nucleophilic and are likely to attack electrophilic sites on substrates. This is the covalent catalysis that we mentioned on the previous slide. The new linkages need to be reversible so that the substrate can leave the enzyme. Electrostatic catalysis results from long-range, non-covalent interactions between oppositely charged groups. A wide variety of metal ions can be found as cofactors in enzymes. Zinc and magnesium are some of the most common ones. Because metal ions have a positive charge, they work well for binding to negatively charged groups on substrates or to stabilize developing negative charges as the transition state is approached. They stabilize negatively charged leaving groups. Binding to the metal ion increases the electrophilicity of the substrate so that the enzyme can attack it more readily. And metal ions can also coordinate to water to make water more acidic. Here you can see that binding of water to metal ions decreases the pKa of water from 16 to values within the physiological pH range. This means that using a metal ion to bind water in an enzyme's active site could provide a good source of hydroxide ion in an otherwise neutral pH. The coenzymes, or organic cofactors, provide access to reactivity that is not possible solely from amino acid residues. Next time, we'll look at factors that influence the activity of enzymes.